Okay. With respect to disk, they're asking plenty of numericals, especially conservation of angular momentum. So let me focus today in that aspect. Okay, now look at this one. A disk of mass m and radius r is rolling on horizontal surface and collides with the inclined surface. Find the maximum height to which the disk ascends on inclined plane. It'll collide. So to what height it will, to what maximum height it will ascend. The overall thing is after. Meanwhile, you try. I'll set the diagram. Are you able to see that one? It'll go and collide with the inclined plane, no? Here. So as it collides, what to do now? What will happen during that collision? An impulse will act. So there's the center. An impulse will act. And there'll be also impulse like this. That impulse will not be there this much. Okay, this impulse due to what? Due to collision. It must be there, no? And this is the O. This is the point P. And it will collide at point P1. And that impulse what happen will pass through the line of action, will pass through the center of mass of the disk. Then this is rough. So suddenly what will happen, and this is also having angular velocity. So this particular point, what happen when it goes and collides here, and impulsive friction also will come into picture. So this you write Jn and this is Jf. So this Jf, what it does, a component of Jn will try to change the velocity V naught. Okay, clear this. And this Jn will act normal, not horizontal. This one. So component of Jn cos theta will try to change the linear velocity. Similarly, Jf, this Jf what happen? Will try to alter the angular velocity. So just after impact, they will have different velocities. V and this omega. They will not have same V naught and omega naught. So why V has changed? In fact, you resolve this. You resolve this V naught. So how you have to resolve? You have to resolve that V naught along the incline. Another is perpendicular to incline. So rough diagram. Let me put. So when it is here, same this when it is here. Ah. Same this, so it will be like this, no? So this will be two components will come, V naught cos theta, another will be V naught sin theta. Okay, I agree this. This will be. So what will happen to V naught sin theta? Since E equal to 0 should be nullified by Jn. Fine. So it will have V naught cos theta. So that then look at that particular impulses that are acting. So immediately after collision, it will be linear velocity will become V and omega. Who will change omega? The Jf, because the surface is rough here. So he's asking to what height it will ascend further. This is what he's asking us. About what point I should consider angular momentum. So here, let's do one thing. This is mg. I think let me consider angular momentum about P1. No? So P1 is something here, not about P, not about the horizontal ground. About point P1, the angular momentum should be conserved. So how to get that angular momentum? So we have to get into the mathematics here. This is R, this is theta. So this should be theta. If that is theta, come for this. So R, so this will be how much? R cos theta. So what is P1? P1 is at height how much? P1 is R minus R cos theta. R cos theta is what? So that P1, if you draw one more line, so about that P1, what happened? It should be conserved, the angular momentum. So therefore, no, the formula will be LP1Z I LP1Z F. Initial angular momentum mv naught R cos theta plus angular momentum due to rotation motion about center of mass. This should be equal to finally MVR. Why R? OP1? Because about P1, no? After collision. MVR plus IO omega. Pure rolling V naught equal to R omega naught, and no slipping occurs is telling. Substitute this, you'll get V and omega. Then afterwards, what happen? You can apply that to what height it will rise. So for that, what you should do? MV square plus I naught omega square equal to MGH. I think definitely you look at the H. H you should not write directly. I think this equation, if I write it, will you agree? See, I just wanted you to, will you write this much? This will be wrong. See, what is right, what is wrong is what you should understand. This is what correct. Because some energy is lost due to this impact. This impulsive friction will decrease angular velocity, and this Jn what happen will decrease the linear velocity. Because of all that, finally what will happen is like there'll be some loss in kinetic energy is there. So you cannot apply directly from this position to this position to maximum height because some energy is lost here. So therefore, first I'll apply how to calculate the kinetic energy of the disk just after impact. You should consider angular momentum not about P. Sir, why don't you consider about P? If you consider about P, what happens? Impulse due to mg and n will be 0. What about impulse due to this? Will be non-zero. So therefore, angular momentum is considered only about point P1. These are some very good questions. I think some good observation, nothing to do, no mathematics big. You have to be very careful whenever that rigid body comes. Now, same problem I think we have discussed previous classes. We have discussed in different way, no? Same numerical. So I gave a condition of like this. What is the condition? The track will be like this. What is the maximum height to? There's a rough surface. What is the maximum height to which it will rise? So when it starts arriving here, so what will happen? V1, this omega 1. How the friction will act? The friction must act up the incline. And V1 omega 1 keeps on decreases, and finally what happen? It come to instantaneous rest. Can you remember? I think we have done this one. In this case, what you should apply? mv naught square plus I naught omega naught square equal to mgh. I think it really matters a lot, no? And v1 less than v naught, omega 1 less than omega. Instantaneous rest. Instead of the track, if it is instead of like this curved, no, if it comes like this, a sharp edge, are you seeing a sharp edge? Definitely what happen, there'll be impact, and that impact what happen will determine to what height here. So definitely you calculate this edge with that one. So which will be greater. So here what will happen? So definitely this is wrong. I think the wrong one. I okay, fine, at least. Huh? This one. So in which case it will attain maximum height? In this case or this case, that one. In which case h will be more. This h will be more compared to this h what we calculated. Because some energy is lost here. No? Some energy is lost due to impact. Hmm? Getting the idea? This will be? Okay, now let me focus on. No, sir, this is smooth. No, you can ask questions. So, like, E is not equal to 0. Then what will happen? The V naught sine theta, what will happen? It may rebound. Chances all that one. So, just to make problem very simple, we have just made V naught cos theta. V naught sine theta will get nullified, in fact, due to E equal to 0. Let's come forward. Read the question. I'll erase that answer, sir. In books, we have 2 discs. I just brought the 3 disc problem. Read carefully. Nothing is there.